let's go ahead and do another example of a tower function because those are a little bit more to it. So let's, out of the homework, 7.3.46, we're going to find the derivative and evaluate it a. So this is what it's going to look like. If I have g of x is equal to x to the natural log of x, and I'm evaluating it at a, and in this instance, a is equal to e, right? E to the first power. All right. So I'm going to put my little side note over here so that we have it. Our tower function little cheat sheet. Let's rewrite this. I know that x to the natural log of x, right? This is the same thing as b to the x. So I have e to the, and bring that exponent in front is essentially what you're doing. Bringing the exponent in front, and then you have it of the natural log of x. Now, if I have natural log of x times natural log of x, that's the same thing as the natural log of x squared. It's just easier to write it like that. All right. Okay, take that derivative. Find our derivative and evaluate it at e. So the first thing is to find the derivative. So here, derivative of e is just e. So e to the natural log of x squared. Then, oops. I take this and chain rule, right? That's the whole point of this. So you can chain rule that. Well, when you chain that, it's kind of a chain in a chain at this point. So you bring the 2 in front, keep the guts, right? And then times it by the derivative of the inside, which is 1 over x. Okay. Now, I have, let's go back to red, f prime of x is equal to, I'm going to rewrite this as what we start with, so x natural log of x here, and then just clean this up a little. 2 natural logs of x over x. And I'll just keep it like that. Cool. There's my derivative. Now I'm going to evaluate that derivative at e. So anywhere you see an x, you put e times 2 natural logs of e over e. Now what do we know? Yeah, inverses. Those cancel out. I'm just left with an e here. These cancel out. I'm just left with that 1 there. So, lo and behold, I end up with, let's go back to black, f prime of e is equal to e times 2 over e. And now then those e's cancel, so f prime of e is 2. Do you see those those e's cancel? I'm just left with the 2. Good. So tower function, here's the moral of this story whenever you're talking about a tower function. This is just an extra example. Convert it. If you have a function to a function, that's the identifying characteristic. I'm not going to say use tower function. It's just a method. If you have a function as your base and a function as the exponent, then this is a method you can use to find that derivative. And you're using the chain rule that goes with it. All right? Okay, great job.